Have you ever watched a helicopter just hang there in midair, defying gravity like it's nothing more than a suggestion? This 10,000-pound machine just sits there, making noise but going nowhere. It seems to mock everything we know about physics. But here's the thing, it's not magic, it's science. Pure physics and engineering working in perfect harmony. The secret lies in these spinning wings. Each blade is an airfoil, just like an airplane wing. Curved on top, flatter on the bottom. This shape is everything. As the blade spins through the air, the curved top forces air to travel faster, creating lower pressure above the blade. Higher pressure below pushes up. That's lift, courtesy of Bernoulli's principle. But there's more. Newton's third law adds to the equation. The rotors grab air and throw it downward. Newton says the air has to push back, lifting the entire machine. To hover, the pilot must generate just enough lift to perfectly balance the helicopter's weight. Not too much or it climbs. Not too little or it falls. Perfect equilibrium. So how does a pilot control this delicate balance? Meet the helicopter's control system. The collective lever controls the pitch of all rotor blades simultaneously. Pull up on the collective, and all blades bite into the air more aggressively. More lift across the entire rotor disc means the helicopter climbs. The cyclic stick is pure genius. It doesn't change all blades at once. Instead, it changes each blade's pitch as it rotates. More pitch at the back, less at the front. This tilts the entire rotor disc, pulling the helicopter in that direction. It's like tilting a dinner plate. The helicopter follows wherever the disc points. Here's a problem. Newton's third law says if the rotor spins one way, the fuselage wants to spin the other way. Without a solution, the helicopter would be an uncontrollable spinning top. Enter the tail rotor, a sideways propeller that creates thrust to counteract this torque. It pushes air sideways, creating a force that perfectly balances the main rotor's twisting effect. The pilot controls tail rotor thrust with foot pedals. More thrust swings the nose right, less thrust lets it swing left. Perfect directional control while hovering. Here's something counterintuitive. Hovering is one of the most power-hungry things a helicopter can do. It's actually more efficient to be moving forward than standing still. When hovering, the helicopter sits in its own downwash. Turbulent air it just created. Move forward into clean air, and suddenly the rotors work much more efficiently. This is called translational lift. A helicopter that can fly for 3 hours might only hover for 90 minutes. Standing still burns fuel like crazy. Hovering demands total pilot concentration, constant corrections with all 4 limbs, fighting every gust of wind, managing ground effect, feeling the machine through the seat of their pants. But this incredible skill saves lives. Coast Guard rescues in stormy seas, firefighting helicopters dropping water with pinpoint accuracy, construction work that would take ground crews weeks, and those breathtaking aerial shots in movies, all thanks to the pilot's hovering skill. The complexity, the fuel burn, the intense pilot skill, it's all worth it for this one superpower. The ability to stop and hang in midair, ready to do jobs no other machine can do. That's not magic. That's the awesome reality of brilliant engineering at work.